In Essential Task 1.3, we are going to be talking about the second unique topic that falls under the umbrella of cognition. In Essential Task 1.2, we talked about creativity, which was broken down into convergent and divergent thinking. In Essential Task 1.3, we are going to be talking about problem-solving techniques, and in addition to that, some of the factors that can influence whether or not the problem-solving techniques that are exhibited are effective in the first place. This Essential Task is one that I recommend as a horizontal concept map. I will give you an overview of the boxes in just a moment so that you can verify that recommendation. And in terms of the text that you need to write down, you only need to write down identify problem-solving techniques as indicated in yellow. What you see here is the entirety of the concept map. Under problem solving, there are 3 different strategies. Then under obstacles, there are 2 separate types of obstacles, one of which is broken down into 2 additional subcategories below. I like to describe this as a 5-column left to right. So if you kind of position your boxes, thinking about the spacing necessary on a horizontal piece of paper, you need 5 columns worth across, or 5 boxes worth, while taking into consideration that the final box all the way to the right has a breakdown below it, which is very common. This is obviously the longest concept map that we've done so far. So far, we've done one that was 3 boxes, 4 boxes, and now we're up to about 7 boxes. This is pretty close to the norm, roughly 7 to 8, sometimes 9 or more. But this is about the average that I would say for the length of a concept map as this year progresses. There are some lengthy ones. There are also some really short ones. But in this Essential Task, we will be talking about problem solving. Problem solving is another word that we use culturally. It's not going to be defined in a specific box, but we should identify what this is. When you solve a problem, you do not know the solution. You have many possible solutions out there, but you sort of have to come up with one and determine which solution is going to be best in a given scenario. You're not making a decision in the sense that you have 2 pizza places and you have to pick one. That's a decision. This is a problem. This is your computer is broken, and you're just going to sit there and keep trying different problem-solving techniques or strategies until one of them works. The very first problem-solving technique is what we call algorithms. Algorithms are methodical rules and procedures that absolutely guarantee a solution every single time. So, for example, if you wanted to break into the locker of somebody in the school, you technically could if you sat there and exhausted every single possibility. You tried every single combo. You'd be there for a while, but you would, in theory, eventually guarantee a solution by doing so. That is what we call an algorithm. Also, anytime you follow a step-by-step list of instructions that is designed to yield the exact same outcome every single time, you're technically using an algorithm. That one isn't as obvious. So, for example, if you follow a recipe, in theory, if you follow the recipe perfectly, you should yield the exact same dish every single time, all things considered. That is an example of an algorithm because the solution is guaranteed. If you follow the steps, step by step by step, you will get the exact same outcome. Many of your math classes are actually built around algorithms, even if it's not a term that you've previously used. Anytime you've been taught a step-by-step list of instructions, whether it's PEMDAS or anything else, you are actually following an algorithm. That assumes that following it perfectly will guarantee a solution. The same is true with chemistry and many other classes. If you are lost and you were at the mall and you couldn't figure out where your friends were, in theory, assuming they didn't move, which complicates this a little bit, but in theory, if you walked into every single store, you would eventually find them. That's not very practical. There are plenty of stores that you're going to skip over because your friends certainly wouldn't go there under almost any circumstance. But in theory, if you walked into every single store, you would eventually find them. That's an example of an algorithm. But they're also kind of impractical. Like, for example, the word below spells psychology. It's been scrambled, and I imagine many of you looking at it could have pretty quickly identified that that was the word psychology. Technically, you could have exhausted all possibilities. You could have rearranged that a little bit under 1 million times, and you would have eventually found the word psychology. But as many of you probably were able to do, there are other techniques involved in problem solving that yield much more practical and quick results. So although algorithms guarantee a solution, they're not necessarily always the best. They have many uses, math problems, cooking. But when rearranging a word like that, it's much more practical to use what we call heuristics. So we'll now be proceeding here to the second box under strategies. Heuristics are mental shortcuts that we've developed based on our prior experience that are much, much faster than algorithms. However, they are quite a bit more error-prone because they do not guarantee a solution. They often yield a solution, but they're not absolutely guaranteed. So going back to the example of being lost in the mall, if you checked the stores that you would anticipate your friends to be in first, you probably would find them in one of those stores, and it would be much, much faster than going one by one down the line. Although that algorithm of going one by one would have guaranteed a solution, you know you would have more than likely used a heuristic by using some type of mental shortcut based on your prior knowledge of their interests and gotten to a solution much faster. Additionally, you probably could have rearranged that word psychology by just kind of looking at it and anticipating what it might be based on the circumstances. This is a psychology class after all. Heuristics also include things like an educated guess and check. Have you ever been doing a math problem and felt like you knew the solution without actually following the formula or the algorithms that you've been taught, and then given an educated guess and check and then realized that you were correct? That was an example of an algorithm, or a heuristic rather. Another example of a heuristic involves using the table of contents to find information about a given term in a vocabulary book or in a psychology textbook. You could start on page 1 and flip through every single page, all 1 to 700, to find a given concept. Or you could check the table of contents and very quickly identify where in the book the information is and get to it much faster than through an algorithm. The third concept under the problem-solving strategies is a concept that we call insight, which can sometimes be called insight learning, so be wary of that possible synonym. This is the very first time that you've been introduced to a brand new symbol. So far we have the N for memory trick, we have the H for history of psychology, and now we have this small letter C. The small letter C indicates what are called contributing psychologists. There are two different types of psychologists in this course. Key psychologists who had major breakthroughs that I anticipate as possible names that you'll find on the AP exam in a context that really requires you to know them, or contributing psychologists, which do appear on the AP exam, but they often appear in the context of a question that you can often answer if you just know their study as opposed to necessarily memorize their name. This is an example of a contributing psychologist. Wolfgang Kohler is an important psychologist, but not an overwhelmingly important name that's an absolute need to know. Kohler conducted a unique study where he arranged a banana in an enclosed area and provided chimpanzees a collection of boxes and small tools, more monkeys to work with or more chimpanzees to work with, and tried to see whether or not they would be able to obtain the bananas at the top of the enclosement, or at the top of the enclosure. What he found is that after a while, those animals would be able to come to a solution. They would struggle for a little while. They would sit there and try different techniques. There wasn't really any rhyme or reason to it, but then all of a sudden the light bulb went off and they kind of had this aha moment. And whether it was stacking the boxes like you see here or utilizing the tools in a unique fashion, it suddenly seemed like these animals determined a solution seemingly out of the blue. That's what we call insight. When you're sitting there struggling to solve a problem and then all of a sudden the light bulb goes off. There's no real strategy involved in it, but all of a sudden you have a brand new idea and you're approaching a problem from a new manner, and all of a sudden you've come across a solution. I do recommend watching the attached video. The first portion of it is not Kohler's work. The second portion in black and white is in fact Kohler's work, and I think it gives you a good indication of this study. It gives you some real footage of the animals finding a solution to the problem, seemingly out of the blue after struggling for quite a while. That video will be attached on Google Classroom. It can also be watched if you just go to Prezi and where to click this. Proceeding on to the final portion of this concept map, we'll be talking now about obstacles that you can encounter when trying to solve a problem. The very first obstacle is what we call confirmation bias. This is a term that appears on the AP exam quite frequently. A confirmation bias is when you are trying to solve a problem or alternatively make a decision. And in doing so, you only look for evidence that backs up your belief. So if you believe your computer can be fixed by turning it off and on, you constantly look through Google search after Google search for why that specific technique and that strategy is going to work. And never take the time to step back and think, is there any evidence against this approach? Could I be making a mistake? Maybe I should take the time to play devil's advocate on my own beliefs. We have the tendency not to do that. It's a cognitive bias that's exhibited constantly. For example, if you're trying to decide who to vote for whether a presidential election or a local election or school election, most people tend to seek out evidence that exclusively confirms their beliefs. Why is this a good candidate? Why is this a bad candidate? And constantly seek out information that confirms their beliefs, whether that's through their news sources, whether that's through who they follow on Twitter and Facebook, who they listen to primarily, and never take a moment to step back and say, I wonder what would happen if I Google search the opposite opinion. I wonder what would happen if I listen to a politician with whom I disagree with. Can I actually refute my own personal beliefs? We seemingly never do that. The failure to do that is what we call confirmation bias. So, for example, if you're looking at what college you want to go to, chances are you've been spending a lot of time looking at the great benefits of that college, only looking at the positives. Make sure to take a moment to look at the negatives to ensure that you're not falling victim to a confirmation bias. The final portion of Essential Task 1.3 is under the umbrella topic of fixation. There are 2 boxes below the term fixation that we will briefly talk about in a moment. The term fixation simply is when you are approaching a problem and you fail to step back and see it from a different perspective. You've been so stuck trying to solve a problem one way that the actual solution went right over your head because you never stepped back or never asked somebody really to take a different view or a different perspective at what you're trying to do. There's a very famous problem that we would be doing in class if we were there, where I would present you with a candle, a box, and some thumbtacks, and I would ask you to light the candle on the wall without spilling wax on my floor or having wax touch my wall. In order to actually solve that problem, the only way that you can do it is to dump the tacks out of the box that I give them to you in and use the box as a tool. Many individuals can struggle with this task because they fail to realize that the box of tacks is actually a tool that can be used. So they sit there and try and tack a candle to the wall, and no matter how you do that, that candle is going to drip all over the wall and all over the floor unless you use the box as a tool. That's an example of a fixation. That is a more specific example of what we call functional fixedness. Functional fixedness is an example of a fixation where you have an object and you fail to look at it in a different perspective, and you fail to utilize it in a way that it's unintended for. So, for example, if you're trying to prop your computer up, if you fail to realize that your phone can easily be used to prop your computer up, that's an example of functional fixedness. Computers are not designed to do that. Or rather, phones are not designed to prop up laptops. That's certainly not an intended use. And if you sit there and you fail to prop your laptop up and you have a really difficult Zoom meeting because it's not angled properly and you didn't utilize the tools around you, you fell victim to functional fixedness. Maybe you're out working in the yard and you need to use a hammer, and the only items around you that even approximate a hammer are bricks. If you fail to use the brick as a hammer, even though it would have been a sufficient replacement, that is an example of functional fixedness. If you're out at the park and it starts to rain and you fail to realize that your newspaper could be used as an umbrella, or at least a temporary umbrella, that is an example of functional fixedness. If you're at a birthday party and nobody brought a knife, but you're at somebody's home who has floss, if the cake, depending on what type of cake it is, if you hold floss really tight, you actually can cut cake really quite precisely. That's another example of overcoming functional fixedness because you realize that an object like floss could be used for an unintended use. Oftentimes, when you see functional fixedness in a multiple choice question, it'll be presented as this individual failed to overcome. Failing to overcome functional fixedness would be not using the hammer, not using the floss, not using the newspaper. Quick side note, this was only something that came up many years ago, but it has to be very tangible items. Like, for example, if you got a math degree and you told me that the individual that got the math degree failed to realize that they could probably break into the medical field with it, that's not how functional fixedness works. It's very tangible objects that you can touch and use. Not using your degree as a way to prop up your laptop, that's functional fixedness. Not utilizing your degree in a creative manner, that doesn't count. The very last term is a concept that we call mental set. Many of you have probably experienced mental sets before. A mental set is when you approach a problem from the same way that you've done in the past, expecting it to work again, but this time the problem necessitates a new solution. And because you sit there repeating again and again and again a technique that has clearly failed, you get stuck repeating a process that just simply wastes your time. So for example, let's say your computer crashed, you turned it off and on last week and it fixed everything. The computer was working fine. Now this week, the computer is seemingly acting the same way. What's the first thing you're gonna do? Probably turn it off and on. That's fine. But if you turn it off and on a second time, a third time, a fourth time, a fifth time, clearly there's something new that's plaguing your computer. You are stuck in what's called a mental set. You need to think about a brand new solution. You need to approach it from a new perspective, like maybe starting in safe mode or asking for help. You can't just sit there and repeat the exact same thing again and again and again. That mental set is going to cause you to fail at your problem. Maybe you're lost out in a new city, and generally speaking, you use your phone when that happens. But maybe your phone battery has died. So you've been using the exact same technique again and again and again. And now all of a sudden you're sitting there without the ability to do so. And your inability to view this situation from a new perspective and find something else that works because you're so stuck in your old ways is going to inhibit your ability to solve that problem. Whether it's the computer or the city, those are all examples of what we call mental set. The second example of a fixation.